Hey, what is up, guys? It's Ason here. Welcome back to episode 11, was it? Alright, so welcome to part 2, which is the trap that everyone's encounter when learning about lists. So, this is one of those things that once it bites you, you spend an hour or more confused. But let's make sure that it never does. So, the question is simple. What happens when you copy a list with B equals to A? Alright, so now watch carefully. I make list 1 here, which is 1, 2, 3. And then I write a list 2, a second list, is equals to list 1. Now this looks like I'm making a copy, right? But now I append 4 to list 1. I touch only list 1, you can see, right? But I didn't touch list 2 at all. But if I print them both of them show 1, 2, 3, 4. Why is that? I never touched list 2 at all, but it changed anyway. Now this might be something that is a bit unfamiliar to you guys, and I face the same thing also. Remember this key you have to remember this key idea. List 2 equals to list 1 does not make a copy. It basically just sticks a second label on the same box. So there's one list in memory, in your computer's memory, and now two names, list 1 and list 2, basically point at it. But the storage itself, the memory, is only one, but two things are pointing at it. So when I change what's inside the box, which is what's inside the memory, through either name or the other name that is looking at the very same box, because remember there's two pointers to the box now, it sees the change. So if list 1, which is one pointer, changes the memory or the list on the memory, list 2, who's also looking at the memory, uh, will also like reflect that change. So there were never really two lists. There were always one list with two labels. Now we call that aliasing. And by the way, this is exactly why strings never tricked you like this. You literally couldn't change a string. So the question never came up. But with lists, you can change them because it's mutable, right? So suddenly it matters who's sharing what list. Now contrast that with concatenation. This time, list 2 is equals to list 1 plus a random list there which includes 4 and 5. This list has no variable attached to it. It's just like a list by its own. Now remember from part 1, plus builds brand new list. So now they are really separate. I append an 8 to list 1 and I print them both. And what you should expect that is they are different. See? So list 1 ends in 8, but list 2 ends in 4 and 5, independent. The plus gave me a genuinely new list. So changing one doesn't really touch the other. So here's the rule to remember. Equals share the same list. Plus and slicing build a new one. If you ever truly want a separate copy you can mess with safely, you slice the whole thing, which is like list 1 bracket colon, or wrap it in list bracket dot dot dot. But mostly, just know that plain B equals to A shares and you avoid this trap. So quick recap here of the whole chapter. Part 1, list whole ordered values, index and slice like strings. They are also mutable, unlike strings, which are immutable. So you're able to overwrite items. Remember the append function is to add, the plus sign is to combine, and the append function returns none. So you don't get a new string, a new list, sorry. Part 2 is where we learn about B equals to A and that it shares one list. So remember the two pointers to one memory story that I told you. And if you want a new copy, you just use slicing method. All right. Now to the bottom of the page is our 3 in-class exercises that I would like you to try out. Remember, if you have any questions or queries, you can always text me on Telegram. And the next chapter, we will learn to march through a whole list automatically. with using loops. So I'll see you there.